Okay, welcome back again. We have what? We have nested quantifier. Means that we have 2 together, 3 together. So my question is what? Do you think quantifier is important to what do you say? To be arranged? For example, if I have for all x there exists y, that one. Do you think with there exists y for all x? Do you think if we play with the order of the quantifier, that will make a change or not? In your mind, just for.
I think yes.
Yes, good. So let me give you the example for your yes. We have, for example, we have what? We have the for each y. Listen to understand. We have for each x there exists y. Which condition is stronger, on x or on y? Of course on x. We say quantifier, we say universal for all value of x. Okay. So I say how we analyze this word, this sentence. We say for all real numbers, means that x all there exists one y or more, which we add with the x, we will get 0. Do you think that one is right or not? Can you give me an example for not to be right? Give me the example to make our sentence to false. 1? No. We have a nested quantifier. Nested means that each one together. Maybe we have for all. Maybe you have there exists. Maybe we have for all there exists. Maybe you have there exists for all. That's called nested, right? Hello? You didn't understand? It was like a maestro, right? Okay. Let me tell you. Maybe you have for all x, for all y. Maybe, right? That's called two quantifier, compound quantifier together. All. Maybe we have there exists. Why? Maybe, right? Maybe we have for all there exists. Maybe we have there exists for all. You got it now, these 4 cases. Or maybe we have more. Am I right? Maybe you have more. So this is called nested. Each one inside to each other, including together. But the important thing is here, which one is the first one? From left side. Which one is the first one? That one is very important. Even there exists or not. Why? Because you have 2 examples. I ask you, you say yes. We have this example. Later, I'm going to reverse that quantifiers for the other example. Understood? So here we have for each x, for all x, bringing any number in real number. Any number that you like. Give me.
2.
Number. Jumara, in real number. True. 2. Okay, that's why I confused. 2. So we have 2, right? My question is, can you find one example to put it here, to make that one to be 0? -2. So means that the statement generally true. Why? Because for all real number, you can find one y. In your mind, instead of 2, you have 0. Am I right? Because I say there exists, so I will put 1. Maybe you say you have square root of 2, minus square root of 2. I say what? There exists square root. Yeah. So generally, even, yeah. Let me change that condition. No. No, your duty is what? To tell me it's true or false. Your duty. And why? Because to understand why it's true, why that one? This is your proposition. This is your sentence. And that one, the condition, quantifiers. Okay? So to show you the result of true, I bring some example for you. I say whatever you like, which number that you like, bring it to here. I can find at least one number such that be 0. You got it? Okay, بلنا والله. Why? During the rest you are going to where? To study or you take a rest? Listen to me again. The condition, we have two conditions. For all there exists. When I say for all means that all real number. Put it in your mind. For all real number. Give me some example. They say 2, 5, 5. Okay. So that's for all. 5, 2, pi, square root of 2, square root of my. Am I right? All real numbers. 0, minus 1, up to you. So this one. Can I find one number for each of them to make it 0, to get a 0? Yes. For example, for 5, I have minus 5. Your friends say pi. I say I can find minus pi. The others say minus square root 2. I say I'll get find 2. Did I get the result or not? Yes. So it means that the generally is true. Understood here? Now? Yeah. If I change it, look at here. There exists y. For each x, x plus y equal to 0. In the previous, no. In the previous one, there is no chance to bring one example to be false, to make it a false. Any of you cannot bring it. Bring whatever you like, I have a y. In R, bring whatever you like, bring it, I have a y. At least one y. But here, he say what? At least you have one y. So I'm going to choose 5. Such that for all x, do we have, sorry. This statement say what? Say here, plus that box equal to 0. He says there exists one y. Any number that you fix. For all x's. For all x means what? Maybe positive, maybe 0, maybe negative, maybe pi, maybe minus pi, maybe 2, minus 2, square root of 2. Bring all these numbers, add with 5, you will get 0. Is that true? No, so you get false. You can see here, these two examples will help you to understand the quantifier and the nested and which one is important and how to play with them. At the first example, kindly stop talking. At the first example, I mean those questions talking. At the first example, we say for all R, we have 1, 1, 1. No, here no, I say no. For all x, I have just only 1. Is that true? If that's true, if I say any numbers with y equal to 0, no. And so false. Of course, you get false. You go. Okay, okay. We write something, we mean something. لا كم يعني عليهم بو همو إكسك بو همو إكسك بلاني كم واق أدوزمو بو هريا كيان نالي بو همو إكسك واتا صفر نيجاتيف بوزيتيف هر جماري أتوانم دانا واق بدوزمو هريا كيان سما كيسكا تو إكسك مباري بدليخو هالم بدليخو نالم يك إكس علم هر إكسك ميتي علي دو علم بو دو أتوانم واق بدوزمو كبي كم بصفر أو قصية كم ورقت بو دوام يعني علم چی؟ علم بو همویان پیکو همو وایکان تنها یک وایم هی وایکا گریمان نوستم اما نوستم با وای اما کم به اکس علم یک وایم هی یک وای لناو ریال نمبرات جی بیتو او وایت چنه بدلی خو ولا دو بمرجع لقل همو اكس كان بكات الصفر شتي هاي اول یک حالت الراسه باقي همي غلطه اما وتمان یک حالت غلط بيه ابدا كاونتر اكزامبل وايا اسم الصفر بميكات الصفر دو بميكات الصفر نو كواتك سلام اما فولسا اما شان true. You got it, dears? Good. Next. طبعا نترك باسي quantifier example like that we talked to about it right now, and that one is nothing, just talking about how to translate it to English. Kindly study that examples because you need to understand actually to solve, to try to solve the exercises, to answer the exercises you need to solve here. Clear? You need to understand and solve that example. Then we say the quantifier, very important. But if we have 2 for all, does not make a change. Okay? That's the equation. Here we solve that one. And there's another example to show you if you write there exists y and for all x, or if you write for all x there exists y, will give you true and false. Okay, so that one is also homework because depending on the other example, just the same. As a content, the same, just the number changed. Instead of x plus y, we have 2 things. We have, for example, we have x plus y again. Good. So this is the nested. How about this table? There is nothing. He told you we have 2 for all, or we have 2 there exist, as we say the main cases. I like that one. So we are mentioning. Okay. Good. Kindly try to solve the exercises. Why I skipped some pages? Because the example mostly look like each other. For example, here he say what? This example. Let me show you. He say change that one. So example number 4 till example number 20, for example, to 16, 14, 18, all of them the same. That's why we skipped the exercises. If you can understand, reply or answer the first one, the third one, you can solve the rest one. Understood, dears? Good. Till here, do you have any question? No. Be patient. No worries. We have a time. Okay. Do you have a question? I know you are tired, but I don't see you are tired or no. My question is, do you have a question? Okay, so don't say I'm tired. I know. Every time you are tired, call 2, call 1. No worries. At the beginning, for example, if your class at 8, you are sleepy. At 12, also you are tired. At 4, you are sleepy. Yeah, hungry. You have many reasons, so don't worry. I have the same. Actually, I'm sharing the same feeling with you. Yalla. So, we have inference. So I'm going to cover this one. It's easy. We have inference. That one, as I told you, just thank you. Close the door. When we say inference, it means that we are going to produce the theorem. Now we are going to produce the theorem because later you have a proof of the theorem. So if you don't know how to make it, you don't know how to fake it, right? You don't know how to separate it. So the argument is what? We have the argument, we have a premises here, we have a validity. What do you mean by all these numbers? We have an argument, premises, and also validity, and how we change the text to the theorem. Because later we have a text, we change it to the things, to the mathematics, to the propositions, like a P and Q. You can see from here, if you have a current password, you can log onto the network. You have the current password, therefore you can log in into the network. So I'm going to change this word to P and Q. I say what? I say having password is P, then log into the network is Q, then we have something else, again P, Q here, then we have another what? Having current password is P again, therefore we have Q. So we change all these one to P and Q and something like that. Did you understand? Of course not, because I didn't say anything. Just think about to read these sentences. Just read the sentences. What we have, he say, if you have the current password, we have a if P, then what? Q, of course, right? Kaka, you know that one. Good. Then this one repeated. So I have P again. Am I right? The compared about P, that P, they are the same. Therefore, I'm going to write that one. P, then Q, P. Therefore, okay, we have Q. So if I want to produce if I want to make a theorem, I say P, then Q, and P will be equivalent or will give me the result, the conclusion will be Q. Just make it. You know, if I give you a sentence, you make that one. So you can see from here, when you say therefore, we have conclusion. Okay, it's called conclusion. Let me find the word of the conclusion. Where's the conclusion? I cannot find it. Conclusion. Understood? So after the therefore, we have a conclusion. Good. Now, look at here. Change that one to P and Q. We have what? He say, I don't care about that one. True or false. I don't care about true or false here. Just make the conclusion and to change to the P and Q. If that one, then that one. So P, then Q. Okay? We know that consequently, therefore, we have what? We have P. Understood? Good. Maybe you don't understand. Just be patient. Read this sentence and help me. I need your help. Yalla. Jamaat, help me. How? I say, it's blue freezing now. Blue freezing now. Okay. Therefore, it's blue freezing or raining. Understood? So use inference. Inference means that P then something, therefore Q something. Okay? That one's called inference. Understood, yes, for that one? Good. Now, I'm going to analyze sentences. Yalla. Just try to learn that one. You can answer the rest. Yes? Wait, Jai. Did you understand inference means what? Good. Now we have what? The following argument. Where's the argument? Where's the proposition? I see it's below freezing now. That one, I'm going to make it P. Tamam? P. Therefore, so I say therefore. Right? Is what? P or Q. Clear? So here's your result. You got it? Hello? Clear. Easy. Yes. That's it. For now, yes. For now, yes. Yalla. And look at me. We have many names. I don't care about the name here. But I care about how to make an inference. Because that one will build your mind to answer the theorem. That's why we say we bring all this one like a storming. We solve the theorem later. So I don't care about the name here, but I care about how to solve it. Look, how we solve that one. We have negation and here. Look at the first P and here, right? Negation P and here. Then I will get that one. So therefore means that then. Did you understand the second thing? When from the example, previous example, show me how to solve that one, how to change it. I say P, then P or Q. Am I right? How about here? How about if I want to solve here, I say P then Q, and P give me Q. Understood? This is the second thing. Did you get that one also? Hello? Can you change that one for me? This example? Example number 4? Yalla. Can you do it? They helped me. That one? And? Q. Then? Am I right? Understood? Easy? Good. Yalla. Help me for the example number 5. Actually, example number 5 is the tricky. Yalla. Let's do it together. Yalla. We need that one, right? Where's the argument? It's raining today. That one is P. Okay. Then will not have a barbecue today. Negation Q. Let me say that, okay? Good. If you don't have a barbecue today, okay, why negation P? Negation P is not raining. Then we'll have a barbecue tomorrow. That's why I say tricky, huh? Negation, yes, Q, no, no. Let me write a sentence. Okay. Wait. P is what? Raining. Okay? Q is what? I'm going to change the Q. I don't say negation Q. Why? Because we say what? Not today. So not today. Let that one be Q. How about that one? Barbecue tomorrow. Yes, another one. It's barbecue tomorrow. Understood? You got it? Good. So there is no negation of Q. Because there is no relation between not today is not equal to tomorrow. Who say that? Not today, maybe tomorrow, after tomorrow, after tomorrow. Am I right? Did you understand? That's why it's tricky. It's nice to understand. So here we are. We have three things. Now I'm going to rewrite. How? I say if it's raining, then not today. So P, then Q. If you don't have a barbecue today, if you don't have barbecue today, not today, got a Q, then we will have barbecue tomorrow. Am I right? Therefore, if today is raining, so P, then we'll have a barbecue tomorrow. So R. Am I right, Jamaat? Did you understand or not? Right. You didn't get it? Okay. We have three sentences. Raining, okay? Not today, tomorrow. That's it. So read here again. Read this sentence again. So that will help you to, when you find the coding is easier, because you deal with that one. When you have a program, you say, well, this was easier than the discrete. That's why. Okay, good. Look at it, Kaka. We have three sentences. The first one is raining. So I say P. So I say if, then, not today, I say Q. You got that one? Okay. Go to that second sentence. Also, I have if and then. So if not today means that one repeated. Not today, then tomorrow. So you use the third one. Right? So raining, not today, tomorrow. So you see what? Not today, we have then tomorrow. Got a Q, R. Am I right? In conclusion, therefore, so means that we are in the other level. Therefore, we are here. Therefore, as we say, therefore this can be showed by these three dots. Therefore, if it's raining, the first one, then barbecue tomorrow, last one. You got it? So here we are. And I'm going to leave that one for you. Why? Because you are going to read each one. Let me give you one clue then. It's not fair to give you the homework without clue. Because we have something here will make you confused with the previous one. Yalla, help me to help you to give you the clue. Day. Here's an example. Show that the premises, these sentences, argument. Okay. It's not sunny. Hello? Why negation? Okay. Maybe. Maybe you are right, maybe you are wrong. Here I am not supporting you at the beginning. I say P in my mind. Why? Because I don't know if it's sunny or not. Did you understand the clue, Kaka? Kindly. I am going to put P here. Even I have not. Why? Because maybe during the sentence, during the argument, if I have it is sunny, you are right. If we don't have, I am right. You get the clue? If you have, like a previous one, we say not today. Why we didn't change to negation? You don't need to change it because we don't have a today, right? We don't have today. If in this sentence I have today, I should put that one negation Q, and for today put Q. Understood? Yes, Kaka. No. My sentence is what? I'm going to check the whole story. If I have the same statement with the not, you are right. So positive, not negative. No. No. We should, if I have two sentences. Thank you for the question. Just be patient. Be patient. Serika. If we have two sentences, okay? One of them there is not, for example, not today. And I have today, so I'm going to make that one negation Q and Q. Let me finish it as you say. Just let me finish it for you, because I know what you mean. But if just we have not today, I'm changing to Q. That's what you are going to say. If I have negation, can I put it Q? When we have not the negation, yes. When you have a negation, not. You got it? Really? Good. That's why I say stop. So if in the sentences, in the argument, in the paragraph, we have not, do not make it negation. Just be patient, look at the rest. If we have a same sentences with the positive part, change the not to negative, positive part to the yes. Otherwise, make it as he say, as he asked, make it a P, not negation of P. Yalla. So read again. Show the premises. Okay. Today is not sunny. In my mind, it's only P. And it's colder than yesterday. Colder, Q. We will swim in R. It's sunny. Now, that one, negation. Let me change to the first one, to the negation, that one to P. Now you got my clue. You got it? Understood? That one will help you to understand easier. Also, you are right, Kaka. You are right, you can change that one to P and the other one to negation. But in your mind, each time you say not with negation. That's why we changed again. You are right. Good. Yes, Kaka.
What's he it's colder than yesterday? Sure.
I don't know. Just read it. It's not sunny today. Or P. It's one negation P. And it's colder than yesterday. Q. Statement getirem. We are going to swimming. R. We are going to shopping. T. You got it? Each sentence by the variable. It's sunny. P. Yalla Jamal. We don't go to swimming. We don't go to swimming. Yalla. Negation R. Thank you. Then we will take a canoe trip. Another one. RST. Anya? If we take a canoe trip, again T, then we will be home. That one that be S, and that one be T, to be order. Up to you. Understood, Kaka? Tamam? Good. So leave that one for you as a homework. We solve the first one. Look at here. Negation and negation. R then P. Negation R T S. S then home T. I will stop here after the homework. So here we are in the resolution. Let me see. Cancel the resolution. You don't need to. Yep, cancel that one. So next lecture, we'll start from 1.7. Kindly do not forget, because the sections are not parallel, that's why. Okay. Good. Stop. You stop here later, inshallah. Just be patient. Let me record it for you. Stop recording.